Next.js 14 introduced an experimental feature called partial pre-rendering. In this video, we will explore what it is, how it works, and why it matters. But first, what is pre-rendering? Typically, when a server receives a request, it renders the page and sends the result back to the client. If a new request comes in, the server renders the page again. We call this end of the spectrum dynamic rendering, because the page is rendered on demand for every incoming request. Pages that personalize content based on runtime information or frequently updated data require this per-request rendering because each render produces a different result. For example, an e-commerce site might show recommendations personalized to each user. However, most applications have some pages that don't benefit from dynamic rendering because they don't depend on any runtime information that would change the result of the render. For example, a company's blog might produce the same result every time it's rendered. We can optimize this subset of pages by doing the rendering work ahead of time. We call this end of the spectrum pre-rendering or static rendering. Instead of dynamically rendering the page on every request at runtime, we can pre-render the page once at build time and push the result to a content delivery network. When a pre-rendered page is requested, the static result is served from an edge region close to the user rather than a runtime server. History time. If we rewind a few years, it was common for web frameworks to specialize in either server-side rendering, static-side generation, client-side rendering, or back-end APIs. This created an all-or-nothing decision where your whole application had to follow a single paradigm, even when it wasn't optimal for some routes. As a fun anecdote, you'd often see a company's blog, dashboard, or API hosted on a subdomain. This was usually a sign a team had to spin up a completely new project in a different framework or language just to have access to a different rendering strategy. As user expectations and industry trends evolved, developers started to experience friction with single paradigm frameworks. Dynamic-heavy apps wanted to statically render some pages ahead of time. Static sites wanted to add some personalization. Server-first apps wanted to add some client-side interactivity and routing. Client-rendered apps wanted to improve the initial load performance and SEO of some pages or serve some back-end API routes. Next.js grew in popularity partly because it offered more rendering diversity. Teams could use the same tool in the same language, routing system, and component model to handle the different use cases of all their routes without having to manage handoffs between different systems. So what does all this have to do with partial pre-rendering? Fast forward to today, and once again, we're starting to reach the limit of single rendering paradigms. This time at the more granular page level. Even the most static pages, like a documentation page or a blog post, sometimes need dynamic elements such as personalized code snippets or a global navbar with the signed-in user. And even the most dynamic pages share huge portions of static content between users. But you've probably already noticed the logical limitation with pre-rendering pages. We can't pre-render a page that depends on runtime information before receiving the request that contains that information. This leaves us with another all-or-nothing decision. Either we statically pre-render the page and lose the ability to personalize any of it, or we dynamically render the entire page on every request. This is where partial pre-rendering comes in. It allows us to combine the benefits and abilities of pre-rendering and dynamic rendering on the same page, making pages as static or as dynamic as they need to be. So how does it work? As a reminder, Next.js currently pre-renders a page at build time unless it uses dynamic APIs like incoming request headers or uncached data requests. These APIs signal the developer's intention and opt the whole page into dynamic rendering at runtime. This means using a single dynamic function opts all its parent components up to the root into dynamic rendering, even if those components don't contain any other references to runtime information. What if we could somehow isolate this side effect and prevent it from spreading upwards? React has a concept of boundaries. Boundaries allow us to design a system that accounts for two opposing modes. For example, a page can be in a functioning or non-functioning state. We can wrap part of the page in a React error boundary and design fallback UI for the potential non-functioning state. If the wrapped UI ever enters this state, the error boundary will catch the error and render the user-friendly fallback. This prevents erroneous behavior inside an error boundary from breaking the rest of the page. Similarly, we can wrap components that include asynchronous operations in a React suspense boundary and design fallback UI for the temporary loading state. When rendering on the server, React will stream the fallback to the client and, eventually, the actual wrapped components once their async dependencies resolve. This prevents async operations inside a suspense boundary from blocking the entire page. Partial pre-rendering extends the usage of suspense boundaries. In addition to async code, we can now also wrap components that use runtime dynamic APIs in a suspense boundary and design fallback UI for the static pre-rendered state. This mechanism prevents dynamic APIs inside the suspense boundary from opting the rest of the page into dynamic rendering. Since dynamic rendering can now be isolated to UI inside suspense boundaries, React can statically pre-render as much as possible at build time while postponing the rendering of UI inside the suspense boundary until runtime. When your app is deployed, the partially pre-rendered result will be pushed to an edge network and globally distributed. At runtime, when a user visits the page, edge compute close to the user will immediately serve the static pre-rendered result. Simultaneously, it would also initiate a request to a runtime server to start rendering the dynamic parts. On the client, the browser can start essential work like painting the pre-rendered HTML to the screen, downloading static assets such as images, fonts, style sheets, and the JavaScript bundle that includes the React and Next.js runtimes, and even making downloaded client components interactive. At the same time, the server uses runtime information such as the incoming request, headers and cookies to fetch data, render, and string the chunks to the client as soon as they become ready. Finally, back on the client, the browser fills in the dynamic holes as they stream in by replacing the pre-rendered fallbacks with fresh dynamic content. So, how exactly is this different from the current behavior? When dynamically rendering a page, there's a period of time between the client sending the initial request and the server computing and sending a response. This period can increase in certain situations, such as when the distance between the user and the rendering server is large, uncached data requests are slow, streaming is not used, or in serverless environments, where the initial request may experience a cold start. Until the client receives the response, the user, or crawler, is waiting and doesn't see anything meaningful. And the browser is idle and can't start any work. Comparatively, with static rendering, the period is shorter because there is no runtime computation and the response is served from the edge. Partial pre-rendering retains the benefits of static rendering, giving the client a significant head start by sending a fast initial response from the edge that allows the browser to begin work while the server produces the dynamic response. In the same way that pre-rendering allows us to optimize the pages of an app that don't change between requests, partial pre-rendering allows us to optimize the parts of the page that don't change. While the lines between static and dynamic are blurring, we can still use the full toolset of both models. For the static parts, we could, for example, use middleware to rewrite to different variants of pre-rendered shells depending on conditions such as feature flags, the user's logged-in state or locale, or data fetching to get the static content of a page from an external source, and incremental static regeneration to update the pre-rendered parts periodically or in response to external data changes. These abilities allow pre-rendered shells to have real content, making them more meaningful than typical loading skeletons. For the dynamic parts, we could use the data cache to cache expensive data requests, or streaming to break up rendering into smaller chunks. Even pages on the extreme ends of the spectrum could benefit from partial pre-rendering. For example, a fully dynamic page that does not pre-render a single element in the body tag can still send the client early hints about the bundle and static assets it will eventually need. And fully static pages have the option to add tiny pockets of dynamicity without migrating to a new model. That about covers the concept of partial pre-rendering. It got a bit complex towards the end, but the good news is we don't have to deeply understand how it works. Don't have to learn any new APIs, don't have to think about infrastructure concerns up front. And, most of all, aren't forced to choose between two all-or-nothing models. Instead, we write code as if our page is completely dynamic, using runtime APIs and uncached data requests as needed, adding suspense boundaries to break up rendering into progressively streamed chunks, and let React and Next.js automatically optimize each part to gain the benefits of both static and dynamic rendering on the same page. Lastly, it's important to note that while partial pre-rendering is a promising new default, it is still in active development and not yet recommended for production. Refer to the Next.js blog for the latest updates. We will continue exploring this new era of Next.js and React concepts in future videos. Consider subscribing for more.